Connecting to iSCSI storage. Well, I have to admit, the last nugget on connecting to fiber channel storage left a little bit to be desired, and really that's because it is so very difficult to simulate fiber channel storage. And in order to have a good connection to fiber channel storage, you have to spend so much money in order to be able to bring one in and show the way it demonstrates. So a lot of the things that we kind of glossed over in the fiber channel storage section, we're going to go into detail on this nugget on iSCSI storage. And mainly that's because due to some of the advances in software-based technology associated with iSCSI storage, we can do a lot better of these ways of mocking up storage so that we can see how it actually works. We are going to actually talk about iSCSI and what it is, and we're going to spend not very long on what the concepts are associated with iSCSI, because they're very, very similar to those that we've talked about already with fiber channels, except the medium is different. And we're going to talk about initiators and targets, but what we're really going to do is a pretty extended example where you can actually do this in your home demonstration environment and set up your own sort of SAN appliance. We're going to use a tool called an open source tool called OpenFiler to create an iSCSI target that we can connect our ESX infrastructure in, and we'll be using that for the duration of this series as our data store for where our virtual machines are going to be hosted. We're going to connect our ESX server into that iSCSI store, and then we're going to talk throughout the entire nugget about the gotchas and the best practices associated with iSCSI storage. I want to start off by spending a very short amount of time going over yet another picture associated with what we're actually putting together with this iSCSI connection. And you've seen this picture before, and it's just only very slightly different. So we've got our usual ESX servers here, just like we had before, and then we've got our data store over here that we've used before. The big difference in what we're doing now as opposed to what we've done before really lies in these connection lines that connect our ESX servers into this storage area network here. The storage area network technology that makes up the hard drives, if you will. I mean, there are some subtle differences between vendors, but really iSCSI storage and fiber channel storage on the drive side, it's all really the same. The main differentiator is how the connection occurs between that storage area network and the ESX box. And the difference in that is really that it's running over copper. It's running over regular Ethernet. All iSCSI is it's an encapsulation of SCSI commands over Ethernet. And so the benefit here is that you can leverage your already existing network infrastructure for the purposes of routing iSCSI commands and iSCSI disk drives back to your ESX servers. You don't have to go and run a bunch of fiber in order to set these things up. Now, one of the downfalls is that in order to set up iSCSI is in some cases typically a slightly lower performing way of connecting servers into their disks. Now, those the performance metrics between fiber channel and iSCSI are growing together in that you're going to, as time goes on, begin to see the same sort of performance out of the two. But historically, at least in the past, iSCSI performance was less than fiber channel performance. One of the unique things that you can do with iSCSI performance is it's very easy to team multiply, and you can add more and more network adapters into your ESX server and team them together just like you would with network adapters to just increase the performance that way. So whereas a typical fiber channel connection is about 2 gigabit, you have a single gigabit on a gigabit Ethernet connection. So I've got 2 gigabit here for a fiber connection, right? And I've got a typical 1 GB here for Ethernet. But what I can do is I can team together a bunch of these Ethernets, maybe times 3 or times 4 or however many I want, to increase the throughput between that server and that storage area network. By doing that, I can begin to approximate what I'm getting with fiber channel. Now Ethernet has there's overhead associated with Ethernet that's not as much there associated with fiber channel, but you still have the ability to team those together here inside of iSCSI to help approximate that performance. What we're going to do is we're going to create a single connection from our ESX server into our iSCSI data store, and using that, we're going to create a data store from the volume that we created. What we're going to use is a tool called OpenFiler, and I'm dragging in a web page here, and this page may be different as you look at it, but the OpenFiler tool is an open source NAS and SAN appliance that allows you to download this appliance, install it as a Linux installation, and then it uses a very nice and clean web interface, so you don't have to do a lot of Linux configuration to set it up. what you want to do is actually download the x86 appliance right here, the OpenFiler NAS-SAN appliance disk 1. And you'll see in here that there's a virtual appliance for ESX and for Workstation here that you could potentially download as well. We're actually going to do a complete installation of this appliance using a CD. And the reason for that is so that we can get a chance to take a look at what the installation is. It's a little easier to get the network configuration set up that way. So you don't we were going to be able to do this without ever having to dig into the Linux whatsoever. So if you download this OpenFiler NAS-SAN appliance in the ISO format, and then load it into your VMware workstation, you'll actually be able to use your VMware workstation as the host, not only for your ESX server, but also for your iSCSI data store. So let's go ahead and actually create that OpenFiler instance using VMware Workstation. So I've already gone to www.rpath.org and downloaded the OpenFiler ISO file. Here it is right here, OpenFiler 22 x86 disk 1. And this ISO file is what we'll use to actually build the operating system. We'll build it here inside of our VMware Workstation instance. So if you'll go there and download that ISO file and then put it in a location where you can get access to it, we're going to create a new virtual machine that is our installation of OpenFiler. Choose custom just like we've done before, make it Workstation 6 compatible. The difference here is that instead of choosing Red Hat Linux, we're going to choose other Linux 2.6 kernel. This is not a Red Hat installation. It's a different type of Linux, a different Linux distro. We're going to call it OpenFiler, and we're going to click Browse here and scroll down, and I believe I already have an OpenFiler folder. There it is right there. We're going to put it in that OpenFiler folder. We're going to give it a single processor and a gig of RAM. So it's got plenty of RAM to be able to serve up the applications or serve up the files that we need, and bridged networking and LSI logic. And we're going to give it a 20 gigabyte hard disk. In fact, we're going to give it two hard disks, neither of which are going to have the disk space allocated at this point. We're going to give it two hard disks. The one's going to be where the operating system is actually installed, and the second's going to be the volume that we'll be creating in order to put our VMDK files on. So openfiler.vmdk. So here's our OpenFiler instance. We're going to edit our virtual machine settings and add in that second hard drive first of all. Here's hard disk and create new SCSI and then 20 gigs. Click next again, and then we'll call this OpenFiler Filer 2, so it's our second hard drive. And then lastly, we need to connect our CD-ROM drive into the ISO image, just like we've done before. So we go in here and connect to OpenFiler. So the first thing you're going to notice as we start this, it's going to begin an installation very, very similar to the ESX installation. All of these Linux distros use the Anaconda installing engine to complete the installation. Once we get to the OpenFiler screen here, we're going to hit the Enter key to install the operating system, and we're going to get pretty much a very similar installation routine, just like we've seen before with the ESX installation. So we're going to be asked the same sort of questions like what is our time zone and what is our network configurations, and et cetera, et cetera. So click the skip button here and launch right into Anaconda. So we're going to go through this, and just so that you're familiar with what you need to do in order to set up the OpenFiler configuration. That way, if you feel comfortable enough with completing the Linux installation, you can fast forward through this part, and when we get to the actual part where we configure OpenFiler, then there's going to be some interesting things that you need to be aware of in order to configure it properly. Come down here and click Next, US English, and searching for the partitions. We're going to choose Automatically Partition and erase all the data. And we're going to remove all the partitions on this system, and we're going to install to SDA that first drive. We're not interested in the second drive at this point. We want to leave that available and unformatted at this point. So I'm going to click Next here, and yes. And I'm okay with the default installation here. I've got 18 gigs in here for the operating system to use. I'm going to click Next. I want to make sure that for my network card that I've configured for this system, this ETH0 network card, I want to make sure to include the physical address for this card, 192.168.0.105 in my case. Well, might be different in your case, and also my net mask. And then down here, I want to make sure that I give it a host name as well, openfiler.nuggetlab.com, and give it my gateway settings, 168.0.1, 192.168.0.70. So these are the configurations I need in order to do the networking properly. Again, if you're using the appliance, you'll have to actually dig into the Linux to actually make these configurations for yourself. But if you do the installation, it's a little bit easier in my book. And then lastly, we've got to give it a password. So we'll type in our password here. And that's it. So this completes the installation of OpenFiler. It's going to go ahead and install a bunch of packages and return itself back to your typical logon screen for a Linux logon screen. Once we get back and once this is complete, then we'll be able to use a web interface to do the configuration of OpenFiler, and we'll do all of the configurations from within that web interface. So I'm going to pause the recording while we install all the packages, because this takes about 10 minutes to complete. And then when we come back, we'll take a look at the web interface and what we need to do to set it up and configure it. Okay, and we're back. And the good thing about these appliances and these VMware appliances is that they're really easy to install, and especially with the Linux backend, that you can use them for no cost. And again, they're pretty easy to manipulate. You'll see in here just in a second that the web interface for this particular appliance is really easy to use. So once we've actually configured OpenFiler and we're set, you'll see here that in order to administer the appliance, you need to use a web browser to go to HTTPS then address :446. We don't really need to worry about the virtual machine anymore, because now we're doing all of our configuration here from within the web interface. The initial username is OpenFiler and the password is password, and that's the default one. When you log in, there's a couple of things we have to do to set it up. Number one, we need to go in and make sure that our time is set correctly so that it's configured to be the same time as the Active Directory domain that we're connecting into. So you'll see here we need to make sure we set the time all right, and there's our time, and let's just check the time over here on our Active Directory domain controller. It's set to 11:57 or 23:57. And then we set the date and the time. Then we need to connect it into an Active Directory so that we have the ability to enumerate users and groups from Active Directory. Here inside of the Accounts tab, you'll see Authentication, and under Standard View, you'll see Use Windows Domain Controller and Active Directory. We're going to put in here nuggetlab.com, and then our domain controller will be dcnugget.nuggetlab.com, and then the ADS realm is nuggetlab.com. We want to join the domain, and then type in our username and password for an account that will allow us to join this machine into our domain. And so once this completes, we'll be able to enumerate users and groups. Depending on what sort of information that you have set up inside of your iSCSI target, you may be using an appliance, you may be using a Linux box. A lot of these are really Linux boxes that are encapsulated as appliances. And so what you're going to see here is fairly similar to how the configuration goes depending on what your iSCSI appliance or whatever your iSCSI tool is. So it's a good idea to actually see this so it gives you an understanding of when you need to set this up in your own environment. For this particular iSCSI target, we know we have a successful connection into our Active Directory when we click this List of Groups tab here, and we see the groups of our Active Directory showing up inside of this list of groups. For us to be able to configure a connection into iSCSI, we have to enable networks. And for us to enable networks, we need to go into our General tab and make available the networks that we need to allow access in for iSCSI. Now remember, iSCSI is a network protocol. And so the same security principles relate to iSCSI commands that relate to any sort of network protocol, because hard drive information is passing back and forth across our network. We can give it a name. We'll call it the ESX network. And we need to give it a host. Now I'm going to open up this network to all of 192.168 and give it a netmask, the 24-bit netmask here, and enable the type for sharing of data instead of a UPS connection. You may want to create specific connections to your individual ESX hosts for the purposes of locking down those connections. And when we get to the ESX half of this, you'll understand why you want to do that. It prevents other people from being able to snoop onto your network and view that iSCSI data store. For the purposes of this demo, this is really a closed network, so we can just put in the network in a pretty high-end network mask so that we can see all the hosts, and all the hosts can connect into our store. If I click Update in here, this creates the network for me, and you'll see this ESX network in here. The next thing I need to do is click on volumes. I need to create not only the physical volume, then I need to create a volume group, and then create a volume in that volume group. If I go here to physical storage management, you'll see that drive that we didn't talk about before, this SDB drive here, you'll see this SDB drive is available to us here in physical storage management. The very first thing that we need to do inside of this location is create a partition inside of this storage array. We need to create a primary partition. We need to create it as a physical volume with starting and ending cylinders about 20 gigs in size, and hit the Create button. Once this volume is created, then we need to add it to a storage group. This process sometimes can take a couple of minutes as it creates the volume. You'll see here now we've got this one volume, a Linux physical volume of SDB1. If we go now to create new volume, or excuse me, volume group management, we can create our volume group that we need to create. So remember, we have to create a partition, a volume group, and then a volume to put into that volume group. You'll see down here that we have a new volume group. We can give it a name. We'll call it ESX, and we'll choose the physical volume we want to add. This creates the volume group. Once the volume group is created, we need to create the volume. Now, creating the volume can take a little bit of time. And so what I'm going to do is I'm going to show you the creation of the volume, and then I'm going to pause the recording while the volume does all the things it needs to do to create and all the formatting processes. And when we get back, we're going to actually start the service that starts the iSCSI target. So there's an iSCSI target service that we need to begin once the volume's created. So I'm going to go ahead and scroll down here, and we need to create a volume in this volume group. Let's give this name ESX1, and then you can give it a description. First ESX volume, and I'll put the underscores in there. And then we want to give it all the space we can, all 20 gigs of it available. And important here, we need to make sure that we choose a file system type of iSCSI. That's what allows us to connect to it remotely. We'll hit the Create button, and this begins the process of creating that volume. You see the volume now is created. There's the volumes in the volume group. And we are ready to begin. And now we want to actually check the properties on it to see what we need to do to configure the volume so it can be presented to our ESX server. I scroll over here to the right, I choose Properties and click Edit here to view the properties of this volume. And I'm going to scroll down here. There's our volume name that we created. And here's some CHAP authentication. We'll talk about that in just a second. And here's the host access configuration for this volume that we've created. You'll see earlier we created that network host, that 192.168 network that we don't want to connect into. By default, the access is set to deny for that network. We're going to set that to allow to update our access configuration, essentially our firewall, if you will, that allows us to expose now this LUN out to our ESX server. The last thing we want to do in here is we want to enable a sense of authentication in here. And this is not necessarily a required step, but when we get into the ESX server side, you'll see what this means on the ESX server side. We have a challenge handshake authentication protocol as a tool that iSCSI can use in order to ensure that there is an authentication, essentially a username and password that occurs between the server and the data store when they attempt to go back and forth with each other. I can put in any username I want, or I can use the iSCSI IQN name if I want. I can pretty much make whatever I want in this location. I'll just put an administrator and the password, and then administrator on the other end and the password. All this says is that in order for the two to actually connect to each other, they need to have the same username and password typed into both locations. I'm going to click Change here to update this information as well. And then the very last thing we need to do then is actually enable the iSCSI service. It's up here under Services. You'll see that there are a number of services here, SMB, CIFS, NFS, HTTP, WebDAV, etc. The one we're looking for here is iSCSI Target. Now I'm going to click the Enable button, and you'll see here that we have now enabled the iSCSI Target. We have now completed all the steps that we need in order to present this volume to our ESX server. So let's go ahead and bring up our virtual infrastructure client here, and it's the same one that we've worked with before. And let me make a little more space here so we can see what we need to see. If we look here at storage adapters, we'll see our iSCSI storage adapter right here. And this is our local storage adapter here, our PCIX. This is the local store that's on the server. There's those 20 gigs. You'll see here under iSCSI software adapter, we have properties and we have all this information that we need to fill in. If we had a host bus adapter for connection into a fiber channel array, you'd also see the host bus adapter here under storage adapters. I'm going to choose properties, and we're going to take a look at, for this iSCSI initiator now on the ESX side, what do we need to do to start the process of connecting into our iSCSI data store. Obviously, the first thing we need to do is click Enable to enable the iSCSI connection, and it's to enable the iSCSI initiator. And what it's going to say is that we need to make sure that we have a service console network port and a VM kernel IP storage port that can both communicate with the iSCSI storage. Now, this is something that if you've set up security in your network and you don't allow your VM kernel IP storage to actually see the data store, the iSCSI store, you're going to have some problems. You have to be able to route both of those connections to your iSCSI store for it to work. Now we're going to say a convenient way to do this is to create a service console network port on the same network adapter as the IP network storage. We don't need to do that because all of our adapters are routable. We don't have any non-routable adapters here, but if you do have non-routable adapters, you would have to actually set that up so it's configured. Once we're ready to go here, we can click the close button here and then reopen the properties for this, and we'll begin to see information about our iSCSI connection. You'll see here that we're already beginning to populate some of the properties here. One of the things about this particular window that you have to know is in order for it to fully function, you have to click to close out of this window and then come back into it. It's just one of those strange windows out there. You'll see here that we have an iSCSI name. This iSCSI name is a default name that is provided for by the server itself. And iSCSI names are set up in a particular format. And knowing that format is probably something good to know for the test, but for the most part, in a lot of cases in the development or in the deployment of ESX, these iSCSI names are really pre-populated for you. You'll see here's our iSCSI alias, which is the host name of the server, and we're using send targets to actually locate the targets. If I go back here to configure again, you'll see that this iSCSI name is actually pre-populated for us again. I'm going to click OK here. The next tab for dynamic discovery allows us to add in the location of the iSCSI server that we've created. In this case, it's the target. So I type in 192.168.0.105, and I'll choose the default port of 3260 for that location. And I'm going to click OK. Now, this is going to take a little bit while it's attempting to go and find this location. It's going to fail in the beginning because we've actually enabled CHAP authentication. In order for us to successfully connect in, we need to populate the CHAP authentication tab as well. Now, I'm gonna pause the recording because this timeout is a couple of minutes long. When I come back, we're going to enable CHAP authentication for this connection. Okay, and we're back. You'll see here that we've connected to our iSCSI server. We don't need status yet because we haven't actually authenticated. We're going to go over to CHAP authentication and configure it for ourselves. We're going to add the CHAP credentials. Again, like I said before, we could use the initiator name, this IQN name right here, as our username to log in, but in our case, we're not. We're going to put in administrator and the password. When we hit OK, this is going to tell us that a reboot is going to be required. We're going to need to restart the host. What I'm going to do instead is actually go back to dynamic discovery and double check the status of this particular connection here. Once we've closed out of this location, and if we come back in, we'll actually be able to see the connection that we're looking for to our iSCSI data store. Go ahead and hit close here while we wait for this connection to initiate. Once we're through, we'll be able to actually rescan this particular LUN to see if we've actually got any targets on this LUN. I'm going to hit the rescan button and hit OK here, and we should very shortly see some targets increase because we've included one single path for our system to be available to see. And it looks like we have a single target in here. Here's our iSCSI name. Here's the target LUN. And it looks like we have a capacity of about 20 gigs on here, and our LUN ID is 0. So you'll see now that most of the configuration, as we said with Fibre Channel, most of the configuration actually occurs on the storage side. The configurations that you need to do here on the ESX side are relatively simple. We identify what the location is that we need to go to. We discover the available targets. We set up any authentication that we need to authenticate to our targets on the other side. And then whenever we're done, we rescan the LUN, and our SCSI target is available to us. I'm going to go ahead and reboot this server because we need to reboot this server to fully recognize the LUN. And when we come back, we're going to go up here into the storage node, and we're going to create a data store on our available SCSI target. Okay, and we're back. So we've completed the reboot of the server. We're now fully available to leverage this iSCSI target. Now we actually need to use the iSCSI target to create a VMFS data store. We have one VMFS data store that we've already created here. This is our local storage. And if you'll see here, if I scroll a little bit over here, you'll see this Add Storage button here. We're going to use this Add Storage button to create a new a data store on this iSCSI disk. You'll see here this is under disk/LUN. If I click Next, you'll see now that unlike before, when we were showing in the Fibre Channel array where there were no available LUNs for us to use, we now have an available LUN, and this is the SAN identifier here. That's the IQN number we were talking about before. We're going to use that. We're going to create a data store on that LUN. The hard disk is currently blank on that LUN because we haven't done anything to it yet. So let's call it Nugget data store here for our data store name. This just needs to be a name that is that you can understand so that you will know later on what the data store relates to and what storage it actually relates to. The next option we get is choosing the maximum file size, and typically you want to set this to a very large size. And the reason for this is if you set a very large block size, then you can have a very, very large LUN size in here, in the order of 2 terabytes for the LUN size. Setting it to a smaller block size means that your smaller files will be more optimized, but your larger files may not necessarily be more optimized. So this is a decision you're going to have to make based off of the characteristics of the files in your LUN, but I'm going to go ahead and choose a very large block size for this particular LUN so that I have plenty of space available if I need to add more extents. I'm going to maximize the capacity. If I wanted to, I can even use a certain amount of that capacity, but I'm going to go ahead and use the full 20 gigs here. I'm going to click Next. You'll see here this is all the stuff that it's ready to go and complete the data store creation. Once the data store is created, we can now then use the data store to put VMDK files on. We are effectively creating or formatting the hard drive, if you will, so that it can be used for the storage of VMDK files. As soon as that process is complete, you'll see here that now we have an available data store. It currently has about 850 meg used with 18 gigs free that we can use as a location for storing our virtual machines. This is the first instance of shared storage that we're going to be able to leverage now once we add in our second ESX Nugget server so that we can share VMDK files across multiple servers. When we get later on to vMotioning, this is actually one of the requirements for vMotioning is this shared data store. And so now that we have the data store available to us, we can go ahead and create virtual machines on that data store by clicking New in Virtual Machine. Now we're going to go into a lot more detail of the process of creating and importing in virtual machines in a later nugget, but I want to show you here just very quick. If I click on Custom and just generically begin to create a machine, now you'll see that I have Nugget Data Store in here as the name of the data store that I want to use. So this is the process of leveraging iSCSI to create an iSCSI data store. So what have we talked about in this nugget? We've talked about all the concepts associated with iSCSI. We talked about initiators and targets. We use this tool called OpenFiler to create a Linux appliance that we can use in order to create a shared data store that we will eventually later on plug our second ESX server into later on. We created a partition using OpenFiler. We created a volume group. We then created a volume on that group and formatted it and made it available as an iSCSI target. We then, inside of ESX, we then connected into that iSCSI target by discovering it using the send targets method. Once we completed that, then we created a data store on that target, and that data store is the location where we'll be storing our VMDK files once we begin to add virtual servers into our ESX infrastructure. I hope this has been informative for you, and I'd like to thank you for viewing.